Let's learn about two data types in Python, that are set and frozen set. Those data types those are built-in data types in Python. They're especially available in Python such that we can make some set operations, perform uh, operations on different sets. So are you aware of set theory? So two sets, and if you combine, there are different operations. You have two sets. Let's say that you have two colors. You want to combine both red, blue, green in one set and orange, yellow, green in one set. And so we can think of both as sets, and we can do some set operations such as union, intersection difference, and symmetric difference. What are these operations? Basically, one thing you need to know: set. In a set, set is nothing but a non-repetitive, okay, unordered. So when you perform union of both sets, if there is a repetitive element in both sets, we write that only once. Yeah. So here we have a union, means combining both sets. Intersection means that we take only elements, values that are member of both A and B. For suppose we want students who enrolled for science and English, as well as we want students, if we are combining students who are enrolled for science and English, as well as who enrolled for maths and English. So if we combine both in these two sets, what would be the intersection? Those who enrolled for English. Okay, so difference means that if you say take a science and English and math and English, if you subtract and make it, get the difference of A and B, which means that you are subtracting effectively both math and English, and you are left with the only science here. Okay, so it gives us the all values in A that are not in B, that is the operation of, that is the set operation difference. What is symmetric difference? Symmetric difference actually gives us the values that are in A and B but not in both. Okay, so this is set 3. How in a Python, how can you define a set? See, if you take can you see my screen? Yeah. So how to define a set in Python? You have set and frozen set. Okay, so these two are classes, and as the name says itself, frozen set is immutable. So you can define a set using curly braces, same as dictionary, but the only difference is that in a dictionary we would be writing items, key value phrase referred as items, but here, just like a list, we write elements here: 3, 9, 4, 9, 8, 2, 9. So check this one, what this contains, why 9 is not repetitive. So set means set is unordered non-repetitive data type. Okay, so even though if there are repetitions, it actually stores that and displays just only once. Okay, so for suppose you can also create a set from, let's say, s2 equal to set of hello world Python. Good. What happened? Check this one. I got all. So this sequence, this set is a class which you can create a set using literal syntax by using curly braces. Otherwise, you can also create a set by passing a sequence. See, Python is a sequence. Okay, s3 equal to, I can pass sequence. List is also sequence, right? 9, 2, 2, 2, 4, 9. Okay, now I check s3. I got only 924. So set is unordered collection. Okay, so here check this one. Why we got D first, E, and this order is not definitive. Okay, so you can't, this is unordered, just like dictionaries. Okay, and but sequences like such as list and tuple are ordered data types. So let's define a set again. Set is an unordered data type or a data structure. Every element in the set is unique and no duplicates, allows no duplicates. And a set is a mutable data type, whereas frozen set is immutable data type. Okay, understood? Set is an unordered data structure, and every element in a set is unique and no duplicates are allowed. And even though if you add duplicates, duplicates are removed by its nature. And these set data types support set operations such as union, intersection, difference, symmetric, difference. And you have seen here, for suppose if I do set x s4 equal to set of apple apple, and you will see p only once, sorry, s4. And as we have discussed, set is unordered. So unordered set is unordered mutable data structure where every element must be unique and no duplicates are allowed. And even though if you add duplicates, they are removed. Only set takes only one element. One of it. So what are operations on set? dir of set. Check. What are different operations? Yes, these are all methods. Those are all methods. And we have seen different ways. You can create a set using literal syntax. You can call a set class, instantiate a set class by passing a sequence. Sequence, you know what are sequence data types in Python? List, tuple, and a now dictionary is a mapping data type. String is also a sequence data type. Okay, and now check this one, S4. Check S. What S I have? 2, 3, 4, 8, 9. Okay, and set is also heterogeneous. Okay, so I can add, you can use add method to add something. See? Okay, and where is it is having another function which is remove. Okay, check this one, it is gone. Right? What pop does? Now there is no such a thing as last because set is unordered. As you can see here, removes and returns an arbitrary set element. Arbitrary means you don't know what would be, yeah, which element you are getting. Okay, so you can, whereas in list, when it comes to list, that is the order data type, so that we are certain that we will get a last element, but here that is not the case. That would be the random arbitrary element. And there is a union. Okay, those different methods are there. We will try them out in a moment. And what is update? S dot update, and you can give any sequence. Okay, try to give that again, but you won't see any update because, and check Q hello world, right? So it is like update method on a dictionary. It updates it. Update takes either set or any sequence data type, and that updates the set on which it is being called. The original set. Since it is mutable, check this one. All operations are making changes to original set because it is mutable. And how to, these are all operations that you know already about clear and copy. Why we have copy? Because if I have set, if I assign that to say sx, okay, sx and s are both referring to same, sorry, not dir, yeah, id of x, id of yes, both are referring to same. If I make changes to sx dot remove w, that is reflected there on yes. So I don't want this thing to happen. In such a case, what I can do, I can use sx dot copy. Check this one. Sy would be the shallow copy of sx. So if I make changes to sy dot remove of r, those are not reflected there on other variables because they are referring to different data structure in the memory. And clear already. For suppose if you see sy dot clear and check sy, it is having empty. That is about the methods that you can use to modify the original set, that are add, clear, copy, and update. And these are all discard. There is a discard already. Hello, can you hear me? Yeah, item can be removed from a set using a discard. Okay, it is same. The only difference between two are that discard function leaves the set unchanged if the element is not present, but on a remove, we get, let's do this one. You have s, try to remove and remove something which is not available, which is 99. What you got? You got the error. But what if discard try 99? Okay, we won't get an error. Instead, we get none. It is something like difference between index for us. If you take a string s equal to hello, okay, check this one. You see there are string methods. We learned a couple of methods such as s dot index of, view this one. Substring is not found. There is a find. What you will get? The difference to, like same way it works. This index, but what both are same. You know how to take s dot find of e, you will get that where it is the first occurrence. But whereas index does the same, but the only difference here is index raises an error, but find doesn't. Same way we have a discard and a remove, whereas remove throws a clear error if that element that you are trying to remove is not available in a set, whereas discard does not produce any error. Instead, it returns none. The value is not available. For suppose check sx dot discard of e. Now e is gone. Check. Okay. Now let's define two sets. Colors. red, okay, blue, green, and yes, let's take x equal to orange, blue, yellow, green, okay, and purple, okay. So check this one. What are different operations here? Difference, okay. So maybe let's, to make it simple, let me take a and b, okay, such that you know we can perform these operations same way by, yeah, union intersection, and we can use that as an analogy. B, a dot difference of b. What happened? Check this one. It is like a minus b difference. Can you see? Okay, what you have, removing, see, from a, yeah, from a we are removing the b difference. So which means that, b is having already blue, b is having already green. Removing them, what you have? Only red. Okay, let's add a dot add, okay, add something which is peach, okay, check a, b. Now do the difference, perform the difference on a difference b. Why? Because see, after removing from a, after removing what is inside b, you are left with peach and blue. Peach and, sorry, not red. Yeah, yeah. Now what? Yeah, perform a union. Sorry. See, there are operators. Check this one. Python is having operators. We can use those operators instead of methods also. See, we are actually we are already using these operators. When you, this is called expression, and the what actually the symbol that is used between operands to perform certain operation is called operator. Yeah, operator, and the variables or values on which this operator is performed are called operands. So here a and b are operands, plus is operator. And these are different operators in Python: arithmetic, comparison, logical, membership, identity assignment, bitwise, and component. There are miscellaneous operators, and we'll go through all of them. And you can use these operators to perform those. These operators acts like operator overloading, but that is not supported. Operator overloading, where if it is used between integers, it acts as a, it works like a addition. If it is used between strings, it works like a it concatenates those strings. But if it is used between two sets, it performs the union operation. Okay, so these operators can be used, can also be used. For suppose, check this one. If you have a union b, you see everything is combined. You can do that. A minus b. Yeah. instead of plus, here pipe is used. Okay. So likewise, these operators, sets actually also supports different operators to perform those operations. There are methods, but those methods can be performed using operators as well. Okay. So A union B, which combines both, just like you have, as you can see in a Venn diagram. And the A minus B is a difference. The same thing you have seen. We have seen that using minus operator, which provide difference means from set A subtracting the set B, which means the set A is having peach, red, blue, and green. Set B is having same, whatever is in set B that are removed. Okay, you have a blue and what you have green. You are left with the red and peach. And what is another operation? You have an intersection. Intersection. Check this one. What is intersection? A dot inter. So what it returns? Anything that is common to A and B. Okay, all elements that are in both set A and set B. Yes, blue and green. Okay, and how can you perform this with the operator A and B? Can you see? A and B, and operator. This is called AND operator that can be used to perform the intersection. And see, intersection is same. If I do B dot intersection of A, which is same, yeah, but B dot difference of A, what happens? Yeah, both are different, both are not same, right? Can you see? But what about symmetric difference? There is a B dot symmetric difference of A. Can you see? That is what it means. Symmetric means, symmetry means same. Okay, so A difference B or B difference A, both are different. They return different values because you are subtracting B from A if it is A difference B. But if it is a symmetric difference, what happens? Check this one. What you got here? Both are same. All you got the same elements. Can you see? You have yellow, you have purple, right? You have a red, you have orange, right? You have peach. Both are same. That is what it means. Symmetric difference means. It means that whatever is not in both elements are removed. Okay, that is what you can see here. Symmetric difference. Okay, so anything, yeah, intersection. Okay, symmetric difference removes elements that are in common. Okay, so you can see here A, right, intersection B. Can you see here green and blue are removed that are in common. You see, you don't have a green here and blue here. And so we have seen, you see, we have seen difference, intersection, and the difference, symmetric difference. We have seen pop remove. union operator. And let's come to what is subset, what is superset, what is disjoint. Okay. So in set theory, what is subset, what is superset, and what is disjoint? So if you have a set, let me show the example. See, if you have two sets like this, B is a superset of A is subset of B. Okay. So for suppose you see B and A are subsets of C. C is a subset of A as well as B. So which means that you see here, if you have a and B, okay, if another set is having all elements, you see it is better explained here. A is a superset of B. Okay, and this 4, 7, 8, 11 are elements inside A as well as B. Okay, if all elements are present in a set that are present in another, for suppose, let me rephrase this way. If all elements in set B are present in A, okay, as well as A contains more elements, so B is a subset of A. Okay, so if not even one element is present, that cannot be a subset, strict subset. Okay, so for suppose there are B contain all elements, but even other elements are there. Okay, B contains all elements that are in A, but other elements are also there, which means which is not a strict subset. Let's see that in action. I hope these are with these pictures it is clear enough, but let's see with an example. A, we have A and B. Tell me if A is a subset of B. C, B, check is subset A. False. Okay. Why? Because B. Yeah, not in it. Yeah. So let me tell you what is a subset of with an example. There are students in a college. Okay, there are different branches: ECE, EEE, CSE. So this college is having only 3 branches. All elements in college are also available in all 3 branches. So each branch is a strict subset of a college, right? Because all students who are in a college are also students in a branch ECE, right? All students in a college are also students in a branch EEE. So these 3 branches are subsets of a college. College is a superset of these 3 branches. Do you understand? And these 2 branches are disjoints because if 2 elements are not having any intersection, any common elements, so we call it as a disjoint. So let's put yes, and let's put a C. Okay, let me take a C here with altogether strange colors. Okay, let's define, yeah, maroon. Okay, and a line. Take this one. A is this joint of C. True. Okay, and C is also disjoint of A because it it works two ways, because disjoint means if you have two sets, both sets are having no intersection at all. So, and let me add a B. Okay, is a B also disjoint? C, yes, true. But if I add a B dot add of line, now check, B is not a disjoint of C. So now B is not a disjoint of C. Of course, C is also not disjoint of B, because they are having an intersection. Now check, if C is a subset of C, false. Okay, check if C is a subset of B, false, because that is not a strict subset, because B is having, yeah, if C is having two elements, B is having all elements, but B is not having maroon. So it is not a subset. Is a C a subset of B? So no. We have checked. Is C subset of A? No. Right? Let's check this one. Is A is subset of B? No. Why? Because it is having, yeah, it is not having orange color. Sorry, it is not having, B is not having, no. B is having many color. Think this way. So subset means small. Okay, subset should contain all elements of its superset. Okay, its parent set. Or if a set A, if set B is said to be a subset, it should contain, let me rephrase, if set B is said to be a subset of A, B should contain all elements, or B should contain all elements in A or less than those elements. Okay, any elements that are in B should be present in A. Yeah, B is not a subset of A. Of course, it is a brain dead question, because if you have more elements than another set, it is strictly, definitely not a subset. And it is having a peach, which is not in a B. That makes it A not a subset of B. Okay, check this one. You have C. C is not subset of neither A nor B. Check D. D equal to define maroon, lime, white, okay, black. Check this one. D dot is subset. No. Why? Because D is a bigger one. C dot is subset of D. True. Okay. Check this one. D is super. Yes. That is what it means to write. If A is said to be a superset of B, and A should contain at least all elements in B and can contain more elements. If B is said to be subset of A, B should contain at least all elements in A or less than elements that are in A. Okay. Yeah, superset means bigger than the, yeah. So if A is said to be superset, it is bigger than B. Okay, because it may contain more elements than B. B is said to be a subset means it can be it is smaller than a set A because it contains lesser number of elements than A, but all elements that are in B should be in A. So check this one. If C is superset, false, right? Okay, now check this one. What is symmetric difference update? So you have A, C, and you have D. Check this one. C, symmetric difference is white and black. If you use update, what it does, it returns the what is difference and it updates that C as well. Do you understand? No. Check this one. Previously, previously C contained maroon and lime. Update means that that symmetric difference. Yeah. Okay. So updates the C with what the result. Same applied for the difference update. Same is applied for the difference update. Check this one. What is difference update? A, you have B. A dot difference, B, each and different. If you use update, check this one before you check. A is intact, right? Update, A is updated with the result of difference. Okay. So you have we discussed add, clear, copy, difference update, discard, intersection. Intersection update is the same as intersection, but on which this it is called that result is set is updated with the result, and we have seen is disjoint, so is subset, is superset, pop, remove, symmetric difference update, union and update. So these are all set operations. So why these are in Python? How these are helpful? You know, these are really helpful if you want to perform operations like let's take one analogy metaphor. You want to check. You have a population in your city. Let's say in a Melbourne, some X population is there. You want, and in Sydney also some Y population is there. That whole population you can think of it as two sets. You want to perform intersection who are vaccinated in both cities. Okay, you can take all people in both cities as two sets and perform intersection. You will get all who are vaccinated, and perform the symmetric difference all who are not vaccinated in both cities. And you can perform this symmetric difference on all cities in Australia, and you will get all people who are not vaccinated. Okay? So likewise, these are quite helpful in real time.